Are we good?
Yeah.
Okay. We're doing grade 10s, right?
Yeah, we're doing grade 10.
Yeah,
maybe before you start, just a few announcements.
Okay.
Grade 10s, welcome again to the program. Today we're doing functions. Just to mention a few things, one of them is that we're going to have a science show at 12. So after your lesson, please come back at 12 because there will be a science show similar to what we had yesterday, but for a different discipline. We still have prizes, so you want to come back for the science show. Yeah, so Ntokozo, whenever you're ready.
Sure. Yeah, all good. Guys, let's just take out the formalities, man. I don't like formal spaces. My name is Nzima. I'm from Northwest University. I'm doing my 4th year, majoring in maths and CAT. I'm doing Bachelor of Education. I'm also a founder of Ignite Academic Solutions, which is a premium brand, a premium education brand. We do extra classes. So I've been working for 6 years this year. We started working in 2017. So I'd like to say I know what I'm doing. I've been around for quite some time. Okay. And then for today, we're going to be doing functions, which is one of the topics that most of you guys are crying about, especially in grade 10. And just know that once you get the basics in grade 10, you won't struggle in grade 11. You also won't struggle in grade 12, right? And I don't know, guys, if you are comfortable, please unmute yourself, man. I don't like working in a quiet space. It gives me anxiety. So if I do ask questions like, do you understand? Please engage with me. It helps to see if we're all in the same page. I tend to speak too fast at times because, you know, I'm comfortable with what I'm saying and understand what I'm saying. Please don't hesitate to stop me if you feel like you're lost. Please, even if it's one person, I believe that we would rather do one concept the whole day today and make sure that everyone understands instead of rushing through everything, but only to find that people are just lost, right? Remember, it's about productivity, not just like bombarding you guys with a lot of knowledge. Those are my ground rules. So today we'll be doing functions, which is grade 11 stuff, grade 10 stuff, I mean. That's the intro. So functions, first thing that you need to know about function is what? Functions, they begin from what? Remember in grade 6, grade 7, we used to do what we call an input, process, and output, right? And then later on, you went to start with functions whereby you would have something like this, to have a number here. Maybe this is going to be your B. And then we had here a rule. Then we have our, maybe our C, right? So these are the foundations of a function, right? So a function, first things first, we've got 4 types of functions. We have a linear function. We have a parabolic function. Others, they say it's a quadratic. It is one the same thing, quadratic. Okay. We also have an exponential. Lastly, we have a hyperbolic. Are we together?
Yes.
Are we still together, guys? Thank you. Okay. So a linear function, what does how does it look like? Let's just first show you how it looks like. It's a graph that you guys have been doing all along, whereby they'll give you first things first. Let's start defining what is a coordinate. We have a coordinate. So a coordinate, it is what? Your x is 2, y. Okay, how does this thing, how do we plot it rather? We say that when my x, remember this is my x-axis, here it is positive, and here it is negative, right? This is my y-axis. Here it is positive, and here it is negative, right? So whenever I'm plotting a point, you've learned it in grade 9, your last topic, which was transformation. They taught you how to plot points. So let's say I have 3:2. It says to me, I need to go where my x is 3, which is can be something like this. This is 3. And then when my y is 2. So where these 2 points meet, that's where I'm going to plot my coordinate. Does it make sense? Are we so good so far?
Yes.
Okay. And then now let's get into the main thing that we're here about. So I have a linear function which has a formula of y is equals to mx plus c. Others, they say that y is equals to ax plus q. They still one and the same thing, right? So first things first, I have my m, which I'm sure that in first term you did analytical geometry, or second term, which your m means your gradient, right? So your gradient, if your m is positive, it means that I need to expect my graph to look like this. It needs to be an increasing graph, right? Or if my m is negative, I need to expect my graph to look like this to show that it is a decreasing graph, right? Because your gradient, it speaks about your slope, how steep or how gentle your slope is, right? For those who are doing geography. And then we have our value of C, right? Or Q rather. Whether you're using C or using Q is one the same thing. So your C or Q, it is what we call our y-intercept. So our y-intercept, it is where our graph cuts on the y-axis. Remember, we have our x-axis, we have our y-axis. So the coordinates where my graph cuts on the y-axis, it is what? My y-intercept. Okay, and then we have what we call a mother graph. So a mother graph, it is a graph that has not been altered, right? That has not been altered. So it means that with alteration, I mean that it has not been improved. It has not been shifted either up or down, left or right. It's just your mother graph. So your mother graph, it says to us, my y is equals to x, right? So what does it mean? It means that if I was to use the table method, which I don't suggest you use, guys, from grade 10 going forward, but we'll start with it for foundation. So let's just do this thing quickly. Okay, so remember, we know that our x is our independent variable, and then our y is our dependent variable. So the value of our x, of our y depends on what our x is. So let's say my x is -2, -1, 0, 1, 2, 3, right? So when my x is -2, what's going to be my value of y? It's also going to be -2, because we said that my y is equals to x, right? So when my x, let me just say this is my x, this is my y, yeah. So when my x, I mean, is -1, also my y is going to be -1. When my x is 0, also my y is going to be 0. When my x is 1, also my y is going to be 1. When my x is 2, it's going to be 2, it's also going to be 3. How do you draw this graph, the mother graph? So obviously, you're going to put these things like this, like this, like this. Okay, so -2, it's -2. When my x is -2, my y is -2 can be here. So this -2, -2, -1, -1. 0 is to 0, 1 is to 1, 2 is to 2, 3 is to 3. So you see that your graph is becomes something like this. Please don't forget to draw these lines, because these lines, they say to us, this graph continues. It doesn't end there. So if you don't write these lines, you're telling me that the graph doesn't continue, right? So that's how your graph is drawn. But in grade 10, we learned something new, which is called an intercept method. So the intercepts method, what does it teach us? It teaches us that for my y-intercept, I let my x to be equal to 0, right? So please, guys, listen to this carefully. What does it mean? It says that if my x is 0, what is my y coordinate to complete this coordinate pair, right? And then for my x-intercept, right? Let me wipe my screen. For my x-intercept, let's get back. Intercept, right? I let my y to be equal to 0. What does this thing mean? It means that what is my x when my y is 0, right? So you see how many coordinates you're going to have? You're going to have this coordinate and this coordinate. Then by having these two coordinates, now you can do what? You can have your complete graph. Let's have our example 1. My example 1, it says to us, draw the following graph. My y is equal to 2x maybe plus 1, right? Remember, I said to us, first thing we must look at the value of our m, right? If our m is positive, of my mind, I need to expect my graph to look something like this because it is positive, right? So I'm going to say, let x be equal to 0. So I'm going to say y is equal to 2. Where there's x, I'm going to substitute it with 0 plus 1. 2 times 0 is going to give me 0. Then my y is going to be equal to 1. What does it tell me? It tells me that when my x is 0, my 1 is going to give me 1. Guys, this is one coordinate. You leave it as it is. You go to your second intercept. So you're going to say now, let your y be equals to 0, right? And then now you're going to say 0 is equals to 2x plus 1. It's an equation, -1 is equals to 2x. Remember, we transposed this positive 1 onto our left-hand side, and then it became -1. Remember, we're looking for the value of x, not the value of 2x. So we're going to divide both sides by 2, divide both sides by 2. Then the value of my x is equals to -1 over 2, right? What does it tell me? It tells me that when my y is 0, I mean, my x is -1 over 2, right? Then now I need to plot my points because you need a minimum of 2 points to plot your points, then you make them a graph. So here's my Cartesian plane. Okay. There's a question or the statement that they usually say in your exams. The diagrams are not necessarily drawn to scale. So that's what's also going to happen when you're doing this graph. It's not necessarily drawn to scale. So this point, the first point, which is this one, I'm going to call it A. This one, I'm going to call it B, right? When my x is 0, my y is equals to 1. When my x is 0 here, my y is going to be equals to 1. So I'm going to move one unit up. So it's going to be somewhere here, right? And then when my x is -half, my y is going to be 0. My y is 0 on this line, right? This line. So -half is going to be somewhere here. Please note, because you're not using any scale, you just need to come back and say, what's the coordinate? 0 is to 1, -1 over 2 is to 0. And then from here, you just join the 2. This is your graph. Are you okay?
Yes.
Any questions so far? Anywhere where you're lost? Everyone is good? Are you all good, guys?
Yes.
Thank you. Okay. Then, after this, there's some interesting things that you need to know. Okay, let's just get back from this one firstly. Your graph, you see that it is increasing for all values of x, right? So remember, read in South Africa, read from left to what? To right, right? So for all of your values of x, your graph keeps on increasing, and increasing, right? So they can ask you, is f of x or g of x an increasing graph or a decreasing graph? So this graph is an increasing graph. Do you agree?
Mm.
Okay. And then also, guys, please note, whether they say g of x or they say f of x or p of x, these all things, they just mean y, right? So the g of x, the f of x is like our names, just different names for different graphs. So they're just naming the graph so that you can't have all graphs being y, but they are all different. Right? And then let's get back to this thing then. We have something which is called a domain. A domain and range, right? So guys, your domain, it speaks about your x values where your graph exists, right? Or rather, valid. And then your range, it speaks about your y values where your graph exists. Okay. Let's dwell on this one, understand it, and we can take it from here. Okay, guys. Domain and the range, right? So remember, do you see this graph? There's a reason why I say you must put these two lines, these two arrows here, right? These two arrows are a formation or are formed by matching this line and this line. This, we get this line. Does it make sense? Guys, please mute yourselves. Again. Thank you. Okay. So your graph goes all the way to the right and all the way to the left without any limitations, right? So also what it means that there's no number that I can punch, right, in my calculator and it gives me an error. So if it gives me an error, it means that number, it is not valid for what? For my graph, right? Or if it doesn't give me an error, it means that that number is valid for my graph. Doctor, please help me with the noise. Are we okay?
You can continue. I think all of them are muted now.
Ted. Vanilla. Literal na. Yeah, record.
Mr. Nzima. Mr. Nzima, please turn on your mic.
Guys, wait. Excuse me, man. When did you stop saying? Do you hear me now?
Yeah.
I'm so sorry, guys. I don't know what happened.
Sharp.
Do you still hear me?
Yes.
Okay. So I was saying that your domain, right, it speaks about your values of x where your graph is valid. right? So in simple terms, it speaks about, are there any values of X which I'm going to punch into my formula and then I get a math error or an undefined, right? So here, I said to you, this, right, it's a combination of the line like going on your right and this one going up. So when they combine, they get you this point, right? This one is a combination of your left and downwards, then you're gonna get this point, right? What does this mean? It means that your graph is still gonna go all the way down or all the way up, right? So you when you speak about your what, when you speak about your domain in this case, is going to say your X is an element of negative infinity Y, because it's going to go all the way, all the way, all the way, right? It's going to go all the way, right? As far as your X is concerned, it doesn't have any limitations or it doesn't have any asymptotes, right? Or you can say my Y is an element, not my Y, my X is an element of real numbers. It is still correct, right? And also looking at your range. So for my range, my Y is an element. What's wrong with my pen tip? My Y is an element of real numbers. Or you can say, if you want to say real numbers, you can say my Y is an element of negative infinity till positive infinity. Are we okay? Are we still seeing the screen?
Yes.
Are we
Nope.
still seeing the screen?
Nope.
No.
Okay, let me share the content again. Are we good now?
Yes.
Yeah.
Okay. So I was saying that for our range, remember your X domain, your Y is range. So your Y is an element of what? It's an element of real numbers again. Or you can say it's an element of Y is an element of negative infinity to positive infinity. Please note, guys, these brackets are round brackets because it means excluded. Remember, guys, you can only approach infinity, but you don't reach infinity. So you cannot include infinity because we don't arrive at infinity. Does make sense?
Yeah.
Okay. So can you please try to draw this graph? Now is for just 2 minutes. I want you to try to draw this two graphs, or one graph rather. Your Y is equals to -3, negative 3x plus 4. Please use the intercepts method to draw this graph. Y is equals to -3x plus 4. We'll mark it in the next 2 minutes. Use the intercepts method. And also give me the domain and the range for the graph.
Yeah.
The domain and the range. Guys, if you're around places where there's noise, please mute yourself. At the 2 minutes past 9, we are marking. Guys, are we winning? Are we okay? Do you have any approach for it? Are we winning?
I have a question.
Yeah, I'm all yes.
Why don't we add the numbers the values that we have when we're including the domain and range?
Okay. It is because the values there, they don't have any significance value. What do I mean by that? I mean that for your let's say for your domain in this case, right? Your value of x, it is a real number, right? Which means it can be 1, it can be 2, it can be 2.5, can be 3. It doesn't have any number which is a restriction. So if there's no number that is a restriction, you don't use that number. So it's going to go all the way to the left, we don't know till where, and all the way to the right, we don't know till where. So there's no number that we can use for that. It does make sense.
Thank you. Yeah, it does.
Can we mark? At 35 minutes past, can you please mark? Just 1 minute. It's 35 minutes past. Let's mark. Okay, guys. Let's check here. First things first, my y is what? Is negative. So at the back of my mind, I might expect my graph to look something like this, right? Because it is a decreasing graph. So let's do the intercepts. For my y intercept, I need to let my x be equals to 0, right? So I'm gonna say y is equals to negative 3 times 0 plus 4. Then my y is gonna give me 4, which means when my x is 0, my y is 4. That's my first pair of coordinates. Okay, and then secondly, I'm gonna say for my x-intercept, let my y be equals to 0. So I'm gonna say 0 is equals to negative 3x plus 4. Negative 4 is equals to negative 3x divided by negative 3 divided by negative 3, my x 4 over 3. Now let's go and plot So we have something like this now. When my X is 0, my Y is 4, which can be something here. My X is 0, my Y is 4. Remember, guys, this is not drawn to scale. So you must always show the point that you've drawn, right? And then when my Y is 0, my X is 4/3. What is the value of 4/3? In decimals? What is the value of 4/3 in decimals?
1,33.
1,33, right? Which is, we can just put it here. So I'm going to say 4/3 is 20. And then, is this a graph now? If I just have these 2 points. Is this a graph if I just have these 2 points?
No,
What makes it to be a graph?
the line joining the points.
Thank you. So now it is a graph. You can say, now guys that know how to draw graphs, you can tell your classmates now that you know how to draw graphs, right? So now it is a graph. What is the domain in the range for this graph? What is the domain in the range for this graph?
Negative infinity and infinity.
Never. Never. What is the domain in the range? Someone else wants to try?
The domain
Yeah.
is X is an element of R.
Thank you. That's how you reply. That's how you answer. We are grade 10s now. X is an element of, don't you say negative infinity, positive infinity? What is that? X is an element of?
R, of real numbers, R.
Okay, that's also correct. And others, besides, the reason why I said never to your answer is because just said to me negative infinity, positive infinity. What is that? Is that it takes it to one end? What is that? Right. So for our domain and for our range, you must say my X is an element of real numbers, or you can say your X is an element of negative infinity to positive infinity. Do you agree?
Yes.
Okay. For your range, your Y is an element of negative infinity to positive infinity. Do you agree?
Yes.
Happiness? Okay. So also remember, this is just this is what it is, a decreasing graph, right? Because it is going all the way down. Are we happy? Let's do a quick intro for our quadratic because time is not on our side. Now we have the second one, which is our quadratic, right? Our quadratic says to us, or our parabolic function, it says to us my y is equals to a x squared plus minus the value of q. Guys, please don't make noise.
Yeah.
Right? So now, what does this thing mean? This thing means that, again, our a, right? It tells us about the shape of our graph. If my a is positive, it means that I'm going to have my graph looking like this, right? It is a smiley face, right? And then if my a is negative, I'm going to have my graph looking like this. Do you agree?
Yes.
Okay. So do you see? So what do you learn from this thing so far? It tells you that negative people, they slow you down. You see, even from the first one, when it is down, this one is negative, it looks down. So you mustn't associate yourself with some negativity. Bad aura, you mustn't do that. Okay. Then now, let's look at this thing. This is also now our y-intercept again. It's still our y-intercept. Okay. Let's look at this thing. I said to you, your a, when it is positive, your graph looks like this. So when your graph is positive, it has what we call a minimum minimum point. Right? When it is positive, it has our maximum point. It's max. Do you agree? Are we okay?
Yes.
Because guys, the moment why the reason I'm saying this minimum point and maximum point, because these two things, they affect your range. So you must make sure that you get it and you get it right. So let's get to drawing a graph. So we also have my mother graph, which is y is equals to x squared. Right? So how do you draw it? It's just like this. No. Y is equals to x squared. So your graph is going to be something like this. If you're using a tables method, you know that, remember what we did I almost said yesterday, what we did on the previous one. Okay. -2, -1, 0, 1, 2, 3. So when your x, this is my x, this is my y. What is -2? -2 into bracket squared. What's the answer? -2 into bracket squared.
4.
4,
4. -1 into bracket
One.
squared.
1,
0,
0,
1,
1,
2,
4,
3,
9.
9. So those are your coordinates then. So it can be somewhere like this. This should be 0 to 0. That's where your setting point should be. This. That's how your graph is drawn. Please note, guys, this is not, you see this thing, when you draw like this, I know that you when you draw graphs, when you draw like this is not a parabola, guys. This is not a parabola. This is something else. Your setting point should only be just 1 point. 1 point. Right? So this is when you are using a tabular method, but we won't use tabular method because your graph is not going to be drawn to scale. Let's draw the grade 10 graph. So my y, quickly, y is equals to maybe 2x squared minus y, right? What do you do? The intercept, I'm going to say, let my y be equals to 0, right? I'm going to say y, 0, is equals to 2x squared minus 1. 1 is equals to 2x squared divided by 2. My x is equals to, my x squared is equals to 1 over 2. Do you agree? Am I looking for x squared? I'm looking for x. Am I looking for x squared? I'm looking for x.
We're looking for x.
For x squared.
X. Not for x, not for x squared, for x, fail. So we're going to introduce the square root this side and the square root this side. Please note, your x here is going to be equals to plus or minus the square root of 1 over 2. I'm going to show you how you're going to use this, right? And then it means that when y is 0, your x is going to be positive square root of 1 over 2. Or when your y is 0, your x is going to be negative square root of 1 over 2. I'm going to show you how we're going to use that. So here we have 2 coordinates. Do you agree? So it's the same as
Yes.
negative square root of 1 over 2 is to 0. And positive square root 1 over 2 is to 0. So this is a coordinate and this is a coordinate. And then let our x be equal to 0. Let my x be equal to 0. And I'm going to have my y is equal to 2, 0 squared minus 1. My y is going to be equal to -1. Do you agree?
Yes.
Okay, so now
Yes.
this means that when my x is 0, my y is -1. Do you agree? Okay, now let's draw the graph. When my y is 0, let me use a different color. 0, -1. It is here. 0, -1, right? Now, that's where this thing comes through. So if you don't have this, you won't have this part. Negative square root 1/2 is to 0. Positive square root of 1/2 is to 0. So now you join your graph, you make it, now it looks like this. Now it is a graph. Do you understand?
Yes.
Yes.
Are we okay? So you see why you need to, if you have you're solving for x, you must always from x squared, you must always give two solutions, the +1 and the -1, because your graph needs to cross from both sides. That makes sense. Are we okay?
Yes.
Okay. Now let's do the domain and the range, then we are done. So the domain, what is the domain about, Konje? What does the domain speak about? Which
The
values?
X, it's the
The
X values which are valid.
Thank you. X values. And then the range speaks about what?
The Y values.
Y values. Great stuff. Okay. Looking at our graph looks something like this. And then here there's -1. Here there's square root of 1/2, 0. Here it's negative square root of 1/2 is to 0. Okay. What is the domain of this graph? When you take a guess, or from what you're seeing, what is the domain of this graph? What do you think is the domain of this graph?
X is the element of -infinity and to +infinity.
Positive infinity. Okay, great stuff. Why? Because this graph is going to go all the way to the left and all the way to the right. So it doesn't have any asymptotes or any restriction, right?
Yes.
So yes, my x is an element of -infinity till +infinity. Are we happy with that?
Yes, sir.
Now let's do the range. That's the next part now. What do you think is the range of this function?
Y is the element of -1, including it, and +infinity.
Okay, what does that mean? It means that your y is an element of including it, which is going to be a square bracket. So do you see why all along we're not using the square brackets, we're only using the round brackets. So it's -1 is to positive infinity. How is the bracket going to be after the infinity?
Round.
The round bracket.
Round bracket.
What does it mean? It means that my graph will touch -1, right? But it will never touch infinity. Does it make sense? It means that as far as my y is concerned, I won't have anything less than -1. It is undefined, anything less than -1. Because do you see that you don't have any graph, anything below this point?
Yes.
Do you see that? Does it make sense?
Yeah.
Yes.
Okay. So with what, guys, I was planning to do with you today, I'm happy. I feel like I've covered everything. The only thing that that we didn't get a chance to cover, it's interpretation. But you all need these things in order to be able to interpret the graph. For this 10 minutes, any questions, any misunderstandings, anything that needs some clarity before we leave? Any questions from your guys' side?
Will
Also,
they be hard? Oh, sorry.
I'm all ears.
Will there be horizontal shifting?
Sorry?
Horizontal shifting, will there be anything about that?
Okay. Remember, your graph going -1, it means it has shifted right? But this is what is our vertical shift, right? Horizontal shift, you're only gonna do it in grade 11.
Okay, thanks, sir.
Sure. Any question? Anyone with any, there was a girl who was saying something. Are you okay with the questions? Clarity, are we happy? Are we cool? Are we fine?
Yes, sir.
Okay. Everyone else?
Yes, sir.
Yes, sir.
Okay. Doctor, I've done my part. Anything from you, sir?
No, nothing from me, sir. That's great. That's good. Thanks once again. Please borrow me those slides so that I will share with the learners.
Okay, I'll just share them now.
Yeah.
Yeah.
Okay.
I will
Thanks.
share them now. Thank you.
Thanks, grade 10s. We are now going to move to grade 11s. But before we do that, let me just remind you that at 12, we are having a science show. So please come back for a science show. And don't forget that we have some prizes to give. We already have a list from yesterday's, or from the people who won yesterday. So today we're going to be adding to that list. Throughout the week, we're going to be adding new people to the list so that we're going to have as many as we can.
Are we having a poll this time around? Doctor, do we have a poll this time around or we don't have a poll? Dr. Simu?
Sorry, I was on mute.
Oh, yeah, I was about to, so I was checking if there's a poll or we don't have a poll this time around.
No, we did not incorporate that this time around, but
Okay.
yeah,
Not a
but
problem.
I think your lesson was good, sir.
Thank you. Let me find now.
Okay.
Sharp, Malaka.
Don't forget to come back at 12, everybody. Don't forget to come back at 12 for the science show. If you want to stay for the grade 11 lesson, you can actually stay. Hi, grade 11s. Kausha, are you there?
Hi, Doctor. I'm here.
Okay, please try to share your screen. Let me see.
Okay. Can you see my screen?
Yeah, please write something. I just want to see whether.
Okay.
Okay.
Yeah.
Yeah, okay.
Okay.
You can unshare your screen because I want to do something first.
Okay.
Are you using the same machine? It means we won't be able to see you then.
Yeah, I'm using the same machine.
Okay. Let's wait for 2 minutes. I see some people are still joining.
No problem.
Okay, let's just get started. Hi, grade 11s. Today we are doing functions. So what is exciting about today's lesson is that it's going to be given by a learner as opposed to a teacher or a lecturer from a university institution. So I'm excited for today's lesson. I hope you also will be excited for today's lesson. We have Kausha Pillay. Kausha, please unmute yourself and greet the other learners.
Good morning, grade 11s. I hope that everyone is okay and everyone's doing good today and ready to do some maths.
Okay. Yeah, if you're ready, then you can start sharing your screen and then
Okay.
go.
Okay, just to make sure that everyone can see me.
Mhm.
Can I be seen? The screen share?
Yeah, screen share, yes.
Okay. Okay, grade 11s, just something to start off before I begin teaching is that I think it's really important to know that functions is an extremely important section both this year and next year. It counts a lot of marks in both your final papers. So it is important to understand the section since next year, the new work that you learn for functions is barely anything. It's only worth 5 marks in the paper. So most of your marks, which is about 40 marks, come from your grade 11 functions in your final grade 12 paper. So it is very important that we understand what's happening today. And I hope that this lesson would help so that everyone is a bit clearer on what's going on with function. So to begin, I'm going to start with the straight line function. So the straight line graph. Excuse me. So this, sorry. So the straight line function, it has the mother graph, which looks as such. It's a straight line. So try to draw that as straight as possible. So it has the standard form of y is equal to mx plus c. So as I'm sure most of you know, that the m stands for the gradient, or you can call it your rise over run, or even your change in y, over your change in x. So this basically refers to how steep your graph is. So if you have a very steep gradient, your graph would move up very quickly. But if you have to have a gentle gradient, your graph would be a bit more shallow. It wouldn't increase that fast. So you could have a negative gradient or a positive gradient. So if your m was a positive, then your graph would move this way, be pointing towards the right. But if your m was a negative, your graph would be slanting towards the left. And that's just some basic gradient that I'm sure most of you already know. So then you get your c value, and your c value is your y-intercept as well as your vertical shift. Sorry about that. Your vert shift. So basically, if your C was a positive, then you'd know you have to move C units up. Or if your C was a negative, you'd move C units down. So the straight line graph is the most basic graph that we have. And I'm just going to put that all together in a sketch right now. So if we had to have the graph of y is equal to 3x plus 9. So this is how you analyze it before you sketch it. So if you just in your mind had to imagine that this was mx plus c, it'll help you to identify which variable was replaced by which number. And by that, I mean, can you see that the m was replaced by 3 and that the c was replaced by 9? So this would make it easier for us to know that now so if m represented your gradient, now 3 is your gradient. And if c represented your vertical shift and your y-intercept, you would know that 9 is now your vertical shift and your y-intercept. So this is important for sketching. So if I just had to draw the graph quickly here, you would know that now your y-intercept is at 9. So you cannot just draw the graph immediately. You would know that your graph is going this way, slanting towards the right. But you cannot just draw your graph immediately. You have to find out what is your x-intercept. And remember that your x-intercept is where the graph intercepts the x-axis. It's where it cuts the x-axis. So to find your x-intercept on any graph, any single graph, you always set your y to 0. That is because on the x-axis, all your y values are actually 0. So if you know the point of one, you can find the other in your coordinate. So if you had to set y to 0, it will be 0 is equal to 3x plus 9. So we take the 9 to the other side, which becomes a negative, and it's equal to 3x. You need to isolate your x, so you're going to divide by 3 on both sides, which is going to give you a negative 3 is equal to x, which means that your x-intercept is now negative 3 and 0, which is around, say, here. So now that you have both your intercepts, you can just very easily draw the graph as such, and don't forget to label. Okay, so in this graph here, are there any questions before we move on to the parabola?
You can go on, Kausha. We're going to take the questions towards the end.
Okay, no problem. Okay. So the next graph is a very important graph. It usually comes out and it's one of the graphs that are tested the most. So this is called the quadratic graph, or as you may know, the parabola, the quadratic function. Okay, so last year you learned that the quadratic function was in the form of y is equal to a x squared plus q. And you learned that this value was your y-intercept and your vertical shift. Okay, and yet your a represented your shape. So you know that a parabola, the mother graph of the parabola, has this sort of form. Okay, and if your a were positive, you would have a happy graph, because if you were happy, you would smile. And if your a was a negative, you would have a sad looking graph, because if something negative had to happen, you would frown. So that was the basics of what you learned last year about the parabola. So this year, a few things change in terms of the form, the standard form, and you also learn a new shift called the the horizontal shift. So this year, we're going to introduce a new variable into the graph, which is the P. So you learn a new form, a standard form of the graph, which is known as the turning point form. Okay, so the turning point form is actually one of the easiest forms that you get. So it looks very similar to what we just had, but it's A plus P, sorry about that, A plus P all squared plus Q. So you can see that there's a new variable introduced here into this standard form. This represents your horizontal shift. So if I just go back a bit, Q still represents your not your y-intercept. Q still represents your vertical shift. And it no longer represents your y-intercept. And I'm going to show you why. So P represents your horizontal shift. And the A still gives you your shape. And the same rules apply for the shape as earlier. So the reason why Q no longer represents your y-intercept is because last year you only drew graphs that sat on the y-axis. So your graph was either like this, or it could have been like that, or even like this. But this year that changes. So your graph is either going to move left or right. So your graph this year could now be something sitting here. Can you see that it's no longer on the turning point, no longer sits on the y-axis? So it could either be something like this, or even like that. You see that the turning point is no longer on your y-axis. So this Q no longer represents your y-intercept. So the reason why that they call this graph the turning point form is because you can very easily pick out your turning point. So can you see that this point here, this P and this Q, okay, that represents your turning point. It goes as negative P and Q. So the negative, can you see that in my equation that the P was a positive? However, when I put it into my turning point, it became a negative. The Q stays the same in terms of the sign. So why there is a sign change between the equation and the function, the coordinate, is because the horizontal shift has a kind of opposite effect of what the equation says on the graph. What I actually mean by that is if your P was positive, okay, you would think that the graph would move, towards the positive values. And if your P was negative, you think, okay, it will move towards the negative values. But it actually has opposite effect. What I mean is that if P was a positive, your graph would actually move towards the left. So if P is, I can just bring this a bit down. So if your P was positive, that would mean your graph would shift towards the left. And if your P was a negative, your graph would shift towards the right. And I'm talking about in the equation. If your P was a negative in the equation, your P was a positive in the equation, because it has an opposite effect when you translate it into a graph. And yes, so basically, it's because whatever makes this bracket not. So can you see if I had to put negative P instead of X, this bracket will give me not, because minus P plus P is 0. That's what gives me my horizontal shift. So if I can just put this in terms of sketching a graph so that everything makes sense. So if I had to give you y is equal to x minus 4 squared plus 9. Okay, so just like we identify our variables as we did with the straight line graph, this is actually a x plus p all squared plus q. So I feel like this makes it easier to identify a variable, so you know which number represents what. So we know that the 9 is the q, so that makes it the vertical shift, and your p represents the 4, the minus 4, so you know that's your horizontal shift. and the A represents a shape. And you can see that A is 1. So if there's nothing here, I'm sure you know that it is 1. So it's a positive. So you know that the graph is going to be pointing upward. It's going to be a smiley graph. So if you had to put that, so we would have, so now your turning point becomes very easy to take out. This is why it's called the turning point form, because it's very easy to just pull out your turning point. So remember we said that the turning point is minus P and Q. So your turning point is minus 4 and 9. So that means that your turning point is actually 4 and 9. So that should sit somewhere around here at 4 and 9. Yes, that should sit somewhere there at around 4 and at 9. So if I can just want to turn the page, let me just right here. So now it's important to find your y-intercept. So your y-intercept is found by sorry about that. Your y-intercept is always found by setting x equals to 0. In every single graph, you always have to set x equal to 0. So you're going to say y is equal to x, I'm going to set x equal to 0. So that's going to be 0 minus 4 all squared plus 9. So if you had to solve for that, that would now be 4 squared is 16, and 16 plus 9 is 25. So your y-intercept is, let me just redraw these axes so it's not so far up and we can see what's going on. So if I had to make that 25, and then that would mean that my turning point is somewhere around here, which is at 4 and 9. Okay, so we can already see that, so from what we know is that the graph is supposed to look like this. So in actuality, you can see that the graph, we don't need the x-intercepts because the graph is not going to touch the x-axis. It's already formed a shape and we already have the y-intercept. So that is actually all the information that we need. But just in case that you weren't able to pick that up and you did solve for your y-intercepts, let me show you what would have happened. So if to solve your y-intercepts, x-intercepts, you always set your y equal to 0. So if you had done that, you would have said that 0 is equal to x minus 4 all squared plus 9. But the moment when you took 9 to the other side and you said minus 9 is equal to x minus 4 all squared, you would realize that now that you have to square root both sides, you're going to get an answer that's non-real. Which means because you see that the 9 sits under the square root, you can't have a minus under the square root. It gives you a non-real answer. So you can see that your roots, so your x-intercepts or your roots are non-real. So that's why you don't have your graph cutting your x-axis, and it just goes up to have a y-intercept. And just to show you one more, so that we do one with the x-intercepts. If I had, for example, the graph of y is equal to x minus 3 squared, so minus 16. So again, this is your q, this is your a, which is a positive 1, and this is your p. So to find my turning point, it's the opposite sign of whatever, so whatever makes this bracket not, which will be 3, and then you just pull out the q value, which is minus 16. So if I can just plot that here. So 3 and minus 16 should be somewhere here. 3 and minus 16. So you know your graph is going up, but now you can't just draw it because you don't know firstly what's your y-intercept. You don't know if it's going to intercept here or intercept here, and you don't know what your x-intercepts are either. So you don't know if it's going to be cutting here or here or here. So it's important to solve for these first before you start to sketch. So if I solve for my y-intercept first, you always set the x to 0. So you're going to say y is equal to 0 minus 3 all squared minus 16. So 3 squared is negative 3 squared is 9, and 9 minus 16 gives you minus 7. So that you know your y-intercept is somewhere around here, which sits at minus 7. Then you can go on to solve your x-intercepts. So your x-intercepts, and you always set y to 0. So 0 is equal to x minus 3 squared minus 16. So you always take the 16 over your q value to the other side. So you can say 16 is equal to x minus 3 squared. Now at this point, you could multiply your brackets out, but it's just a bit unnecessary in this case because you see when you have one term on the left-hand side and one term on the right-hand side, you can just square root both sides. So if I had to square root both sides, remember when you square rooting a number, you always get a plus minus, because if I had to ask you what was 4 squared, you would tell me 16. But if I also had to ask you what was negative 4 squared, you would tell me 16 as well. So the square root of 16 is actually negative 4, or it can be 4. So you have to include both answers. So on this side, the square will cancel with the square root, and we'll have negative 4 is equal to x minus 3, or positive 4 is equal to x minus 3. So now you solve for x, and that will give you your 2 x-intercepts. And I'm sure you know that the parabola always has 2 x-intercepts. So x here will then equal to negative 1, and x here will then equal to 7. So I just took the minus 3 to the other side, and I said minus 4 plus 3, which gave me the negative 1. And for the positive 4 plus 3, I just added it, and that gave me 7. So you know your points of intersection are now at 7 and at minus 1. So if I can just join all these points up nice and neatly, that will give me my graph. Don't forget to label your graph, which is x minus 3 squared minus 16. So what I also want to point out is the fact that the turning point, the x coordinate of the turning point, also gives you a line of symmetry. So can you see here that 3 was the x coordinate of your turning point, but at x equals to 3 is also a line of symmetry. And you can see this as well as by your x-intercepts. So can you see from 3 to 7, there's a difference of 4 units. There's a difference of 4 units. And from from 3 to negative 1 is also 4 units. So it's a reflection about that line. So can you see that this half here is exactly the same as this half here. Okay, so that's also the axis of symmetry, and that can also be very useful if you have your one turning point and your turning point and your one x-intercept. You can just solve for the other x-intercept by symmetry. Okay, so let's move on now to the next type of parabola. So there's also one more form that you learn for the parabola, which is called your standard form. So your standard form says that y is equal to ax squared plus bx plus c. This looks a lot like your quadratic, your trinomial. You know, remember when we did quadratic equations, this was your basic trinomial. And that is basically what we are sketching. We are sketching a trinomial, a quadratic function. So this a still gives you your shape. That didn't change. And your c is now your y-intercept. Okay, so the c is your y-intercept, and the a gives you your shape. So if you look at B, now we got this new one, B, we haven't seen this last year. So the B actually helps you to find your turning point. So your turning point can also be known as minus B over 2a and f at minus b over 2a. So what that actually means is that once you find the value of minus b over 2a, and when I say that f of minus b minus 2 over 2a is that you substitute that value that you found back into your equation that you have here, and that will give you your turning point. So I know that sounds a bit confusing, so let me show you what exactly I mean. So it's going to be, so for example, if we had x squared plus 2x minus 24. Okay, so let us see. So our a is a positive, so we know that the graph is going to do this, and we know that it intercepts at minus 24. The y-intercept is minus 24. Okay, so can I just do this, and we can put in what we already have. So minus 24. Okay, so now we can find the turning point using this equation here. So your turning point is minus b over 2a and f at minus b over 2a. So our b is a 2. So minus 2 over 2a, which is 1. Okay, that is going to give you minus 1. And if you have to substitute, so the next part says f at minus b over 2a, which means whatever value you found here, you substitute it back into this. So if I just had to substitute that back in, you would see it's minus 1 all squared plus 2 times minus 1 minus 24. So that's 1. 1 minus 2 is minus 1. Minus 24 is minus 25. So your turning point now is minus 1 and minus 25. So that should sit around here at minus 1 and minus 25. So I still can't sketch this right now because I do not have my x-intercepts, and I'm trying to solve for my x-intercepts. So if I can just write maybe up here. So for my x-intercepts, we always set y to 0. So we're going to say 0 is equal to x squared plus 2x minus 24. So this is your basic quadratic equation, and you know that once you have a trinomial, your main aim is to factorize. So you can see that this is a negative, so you open up 2 brackets. And since it's a negative, you have 1 positive, you have 1 negative. The factors of 24, that when they make a difference, that's gonna give you 2 is 6 and 4. So the bigger factor gets the sign that the b has. So you can have 6 here, and you're gonna have 4 here. So then you just solve for x as you normally would. So you'd say x is equal to minus 6, or x is equal to positive 4. So that would mean that your x-intercepts are around here at 4 and around here at minus 6. So if you just draw that up as such, and don't forget to label your graph. So again, you notice that the turning point, the x value of the turning point is still the axis of symmetry. So you still have a 5-unit difference here. So from minus 1 to minus 6 is a difference of 5 units. And from minus 1 to 4 is still a difference of 5 units. So that axis of symmetry still applies. So you must keep that in the back of your mind because it's very important for the graph interpretation. Okay, I think that should be it for the quadratic, and I'm now going to move on to the hyperbola. So the hyperbola, it looks like this. It's like it's a graph cut in half. It has 2 parts. It can either be like that or like this. So it's important that when you're drawing these graphs, not to forget to draw the second half, because it happens a lot. People draw the first half, and then they forget to draw the second half, and then you lose all of your marks. So always remember, you have to draw both sides of it. That is what makes up the one graph. So the hyperbola, last week you learned that it has the formula of y is equal to a over x plus Q, and your Q again represents, okay, so now your Q it still represents your vertical shift, but it also represents your horizontal asymptote. Okay, it represents your horizontal asymptote. And you know that so you knew that x could not equal to 0, because if x was 0, this whole thing would be undefined, and that you cannot have something that's undefined. You can't sketch undefined. It doesn't exist. You can't draw it. So at this point, x could not equal 0, and therefore was your vertical asymptote. It was this y-axis. Remember, see how graphs never touch the y-axis? They always go as close as possible, but they never touch because it was asymptotic to the the x equals 0 line, which is your y-axis. So this year, our graphs are now going to shift. So your vertical asymptote now shifts towards either the left or towards the right. Yes, someone has a question? You can unmute and ask.
Yeah, you can continue, Kausha. I'm just trying to see how to manage the unmute.
Okay.
Yeah.
Okay. So your vertical asymptote is now either shifting to the left or to the right, because now in grade 11, our new thing is our horizontal shifts. So your standard equation now changes a bit to give you, oh, sorry, and your A also represented your shape. My God. Okay, so A represented your shape. So if your A was a positive, your graph would look like this. And if your A was a negative, it would sit in these two quadrants. So if A was positive, it would sit in the first and third. And if A was a negative, it would sit in the second and fourth. So this year the equation changes a bit, and let's go to a new page. Okay. Sorry about that. So we can now do the new equation for grade 11, which is y is equal to A over x plus p plus q. Okay, no problem. So how this works is that the P still represents your horizontal. The P still represents your horizontal shift. Okay, so this represents your horizontal shift. And like we saw in the parabola, okay, if I can just go back there for a second. Remember I said that the shift of the horizontal, it has the opposite effect on what is in the equation to the graph. So can you see how it was -3, but can you see that the graph shifted 3 units to the right? The graph went more towards the positive side. So it does have, that's what I was trying to illustrate by saying that the graph shows the opposite effect than what the equation says. So here, similarly, in the hyperbola, you're going to have the same thing going on. So what gives you this vertical asymptote here is that this bracket, whatever is here, cannot equal 0. Because if it equals to 0, you're going to have an undefined, you're going to have a point that's undefined. So generally it is minus p, but you're basically solving for what makes that bracket 0. And your q here still represents your horizontal asymptote. And your A still represents your shape. And it also represents your, Q also represents your vertical shift. So I know this vertical shift and horizontal asymptote sometimes can get confusing. Is what I'm trying to illustrate that is that in the mother graph, your vertical asymptote, your horizontal asymptote was sitting on your On your x-axis, it was like this. But if I had to move the horizontal asymptote up, it will also indicate a vertical shift. If I had to move the horizontal asymptote down, it will also indicate a vertical shift. So the horizontal asymptote gives you a vertical shift. And in the other sense is that your mother graph was asymptotic to your your y-axis as well. So you know that they couldn't touch there. But if you had to move your y-axis, it shows you a horizontal shift. It shows you a shift of left to right. So if you had to move the asymptote, it shows you a shift from left to right. So horizontal shift is vertical asymptote, and vertical shift is the horizontal asymptote. Someone has raised their hand. If you have a question, you can unmute and ask. Or is that still a problem with the problem of unmuting?
Yeah, we're gonna unmute everybody after you are done.
Okay, so it'll be at the end. Okay. So, okay, so basically the horizontal asymptote gives you a vertical shift, and your vertical asymptote shows you your horizontal shift, your shift from left to right. So let's put this into practice when we are sketching. So if I had to have y is equal to 4 over x minus 3. Okay, wait, hold on. Of x minus 2. Oh, okay, hold on. Okay, of x minus 2 plus 3. So if that had to be my equation of my graph, okay, so this 4, it represents my a value, the 2 is minus 2 is the p, and the 3 is the q. So we know that the graph has shifted up by 3 units, and that the graph has shifted 2 units to the right. So if we just had to start to sketch that. So whenever you're drawing your hyperbola, you always put in the asymptotes first. So this gives you, I said, your horizontal asymptote. So this value gives you a horizontal asymptote. So if I can just sketch that in there, and always label your asymptote. So this is a y line, and that's equal to y is equal to 3. And you're going to also sketch. So what makes this bracket not is what gives you your vertical asymptote. So you can see at 2, you have x is equal to 2. So you can see that now your two asymptotes have now formed a new sort of axis. So this was your original axis here. Let me just put that in pink, maybe it'll be easier to see. So this was your original axis, and then can you see that your vertical and your horizontal asymptotes have actually created a new type of axis. So you know that your graph is going to sit in the first quadrant and in the third quadrant because your A is positive. So it always happens as such that a little new quadrant is created here. So you always go as close to the asymptote as possible, never touching it. So you get like here, then you go as close, but never touch. So here you don't even really have to find out coordinates. You just have to sketch it in that little quadrant that you created for yourself. But if you look at here, which is my third quadrant, I have my original axis in the way. So I don't know where the graph's going to intercept and at which point. So now I have to solve for my x-intercept and my y-intercept. And so your x-intercept, you're always setting y to 0. So 4 over x minus 2 plus 3, we're going to take the 3 to the other side. It becomes a negative. So minus 3 is equal to 4 over x minus 2. So now we have an equation that has a fraction in it. And since it's one term, we just multiply by both LCDs, by both denominators. So you're going to apply 1 there, and you're going to multiply minus 3 into x minus 2. So, and you drop the denominator since it's an equation. So minus 3 into x minus 2 is minus 3x plus 6 is equal to 4. So now you solve for x, which is going to give you minus 3x is equal to minus 2, and you're going to have that x is equal to 2 over 3. The negatives cancel. So 2 over 3 is actually, in terms of decimals, is 0.66. So you can leave it as 2 over 3, but the reason why I wanted to find out what it is in decimal values is that so I know where exactly it sits, because I can't look at my axis and just say, okay, this is 2 over 3. I have to like determine where about between which two integrals it sits. So if it's 0.66, it's going to be really close to your axis, and that you can just write it just 2 over 3. You don't have to write 0.66666. And now you can proceed to solve for your y-intercept. So your y-intercept, you always set x to 0. So y is equal to 4 over 0 minus 2 plus 3. So 0 minus 2 is minus 2, and 4 divided by minus 2 is minus 2 plus 3, which gives me positive 1. So it intercepts here at around 1. So now these will guide the way that your graph goes. So can you see it'll do something like this? So again, you start very close to your asymptotes. You come down, you do your intercepts, and you go really close but never touch. So that is your hyperbola and how you sketch it for grade 11. Okay, so now we're going to move on to the exponential graph, and the exponential graph also gets tested quite often. And I know that many people really get confused with this. So I'm just going to try my best to make it a bit clearer for you. So the exponential function. The exponential function, it's the same thing. So last year you learned that the exponential function is y is equal to a b to the power x plus q. So like in your hyperbola, the q represented your horizontal shift. So here your a still tells you my shape, but the shape works a bit differently now. So you know that the mother graph for the exponential could either be like this or like this. It depends depending on your b value. So the shape of a, so the a tells you whether it lies above, and remember that this is also asymptotic. It's asymptotic to the x-axis, just like y is equal to 0, if you'd like to label it. This line here is y is equal to 0. So at this point, your a is going to tell you whether the graph sits above your asymptote or below your asymptote. So if I had to draw just an asymptote here just to show you, so if your a was positive, your graph would either do this or this, depending again on your b value. And if your a was negative, your graph would either do this or do this, again depending on your b value. So now the way this b value works is that it has a restriction. Okay, b has to be more than 0, and b can never equal to 1. So the reason why b can never equal to 1 is because if you think about it, b equal to, if b was 1, so if I said, and so if I had to place 1 here and raise that to the power x, 1 to the 1 squared is 1, 1 cubed is 1, 1 to the 100th is still 1. So you're just going to end up with the same point recurring over and over. So that's why we say that b cannot equal to 1. And we have to have b is more than 0 because you can have it. You see, the a value now represents whether it's a negative or a positive. So for example, if you had a minus b to the power x, what you have is actually minus 1 times 3 to the x. So this a is the minus 1 and the b is the 3. So that's why, to keep it simpler, we just say that b is always above, is always a positive. Okay. So in your B, so remember I said that this now depends on your B. So if your B, so you can see that if B must be more than 0, but it can't equal to 1. So that means that B can either be a fraction or it can be a whole number. Can be a whole number. So if B was a whole number, so like a big number like 2 or 3 or whatever, and you could also have B as a fraction, which could be like 2 over 3, 1 over 3, 2 over 4, and stuff like that. So when your B has a fraction value, okay, when you look at your asymptote, it always starts very close to the asymptote in the positive, on the positive x-axis. So can you see that if your, let me just draw that a bit lower. Okay, so if your B was a fraction, say this here was my asymptote, your B always starts very close to the asymptote from the right-hand side, and it then goes up. And if your B was, if your A was positive, and if your A was negative, while B being a fraction, it still starts very close. So now the A says below, but it's still very close to the asymptote, and then it goes further away on the right-hand side. So now, so this is if your B is small, you start close to the asymptote, okay? So kind of running out of space there, if I can just draw it here on the side. So now if your B was big, so a whole number, if B is big, you start far away from your asymptote on the right-hand side and you come closer. That if A is positive and if your A is negative, while B being big, you start far away from your x-axis on the right-hand side and then you move closer. So you move this way, like that. So for big, there's a big difference between the two, and for small, there's a small difference between the axis and from where the graph starts. So if so you see this here, what we learn is the horizontal shift. But unlike in the other previous graphs, you don't really see the shift happening, in a sense that you can't really pick it out. Like, so for your parabola, you could see that, okay, it moved to the left or it moved to the right. But in your exponential, you can't really see that a shift has taken place. So your sketching is still more or less the same. So this year you learn it in the form of A times B to the power x plus P plus Q. So this still represents your horizontal asymptote and your vertical shift. And this still gives you my shape. And if depending on whether B is big or small, so you have to take both B and A into account when determining your shape. So you can't just only look at A or only look at B. You have to fulfill both categories of it, two things. So it gives you also your shape of the graph. So this plus P here, right, it represents your horizontal shift. But you don't physically see, sorry about that. You don't physically see okay, you don't physically see your horizontal shift. I'm just trying to see, where did my thing go? Okay, sorry about that. So you don't usually see your horizontal shift. So I'm going to sketch one for you just to show you what I mean by that. So what I actually mean by that is that when you have your, so say y is equal to 3 times a half to the power x plus 2 plus 4. Okay, plus 4. So here, your horizontal asymptote is sitting at plus 4. So y is equal to 4. So you know that your graph is going to actually lie above the asymptote because A is positive. But you don't know whether it's going to go this way or whether it's going this way. You have to look at your B. So your B is small, so that means it's going to start a small distance from the right-hand side and go further away from the axis as it moves on. So we don't know exactly what value that it is cutting here. And so now we have to solve for the y-intercept. And to solve for the y-intercept, you always make x naught. So you're going to say y is equal to 3 times a half, 0 plus 2 plus 4. So 0 plus 2 is just 2. So a half squared is actually 1 over 4. So I'm going to have 3 over 4 plus 4, and that's going to give you it's going to give you 19 over 4, which is actually in decimals 4.75. So 4.75, it should be around here, but you can write it as 19 over 4. That putting it to decimal was just to show you where exactly it lies. You can't just guess where 19 over 4 is. So now if you just sketch it as such. So you see we started very small from the axis because your B was small, and you just went upwards. And you went upwards, you hit the y-intercept, and you went further away from the asymptote. So can you see that looks very similar to the shape of the mother graph? That the shape doesn't really change. So your only thing that it has effect on is actually a y-intercept, because your y-intercept sometimes may no longer be a whole number. Remember before it was always 1 above the horizontal asymptote, but now it may not be a whole number. So you see that we got 4.75. So in terms of shape, it doesn't make a difference, but in terms of the points, it does. So your graph still looks the same. So that is it for the theory, that the new theory that we have learned in grade 11. And just to consolidate what we have just done, I would like to go through a past paper to just show you how exactly to analyze this graph, because I think it's important that once we know the theory, know how to use it in terms of the exam. So I think now I'm just going to do the 2018 November paper, and I'm looking at question 5. So you can actually find this paper. There is a good site, and it's called, let me just write it for you. Okay, so this site is called testpapers.co.za. So this is where I always find my past year papers from, and it doesn't only have it for maths, it has it for all other subjects that you do. So you can access a lot of past papers through the site, and I've always find that a very good revision for your exam in any subject, not just maths. So let's look at this paper. So this paper, this is a function question, and just to remind you of how important functions are in grade 11, is that can you see that this is 21 marks, and then there's also more functions, which is 23 marks. So can you see that how many marks that functions count for? So it's really important that you know functions really well. Alone in this paper, it's 44 marks. So it is a big chunk of your paper, and it's very important that you do well in it. So let us analyze the question. So the question says that given f of x is 4 over minus 3 plus 2, and given that g of x is x plus 2. So you can identify that f of x is hyperbola and g of x is actually a straight line graph. So it's important to first notice what graph you're working with so that the theory for each graph comes into play. So for 5.1, it says write down the equations of the asymptote of f. So you know, let me just write these equations back on my page. So if 4 over x minus 3 plus 2, and so that was for f. And for g of x, it was x plus 2. Okay, so the first question asks for the asymptotes of your f graph. So for your f graph, you know that whatever makes this not 0 gives you an asymptote, and that this gives you an asymptote. Now be careful, they asked you for the equation of the asymptote. So if you just go and say 2, and if you just go and say 3, you get 0 marks. So when they say equation, they need you to give you the full thing. So remember when we labeled it on the graph, when we labeled the horizontal asymptote, we said y is equal to something. And when we labeled the vertical asymptote, we said x is equal to something. So you have to write the equation. That's the equation of your asymptote. So the Q gave you my horizontal. So you're going to say y is equal to 2. And for your vertical, it's whatever made that 0. So x minus 3 equals to 0. So x equals to 3. Then you're going to say x is equal to 3. And that is only when you write the equations in these forms for your asymptote will you get the mark. So let us look at the next question quickly. Okay, so now it says write down, determine the x-intercept of f. So x-intercept, any graph you look at, always set your y to 0. So they're looking at the f graph, which is this graph. So you're going to say 0 is equal to 4 over x minus 3 plus 2. We're going to solve it. And when you take your 2 to the other side, it's going to become a negative 2. It's equal to 4 over x minus 3. Just going to write up here. And now that you have a fraction equal to a fraction, you can solve it by timesing the denominators on each side. So minus 2 into x minus 3 will give me minus 2 plus, will give me minus 2x plus 6 is equal to 4. So I'm going to solve for that. And then you're going to say minus 2x is equal to minus 2, and you take that to the other side, becomes negative. So 4 minus 6 is minus 2. Divide both sides by negative 2, and that gives you 1. So they asked you for the x-intercept, and when they say that, they mean the coordinates. So if you left it at this, you would lose a mark. You have to go further to say it's 0 and 1. You have to write the x-int as 0 and 1, because remember, the x-intercept is a coordinate. It's not just one value. You have to write it as a coordinate. You have to put and the reason why it's 0 is because you know that on your x-axis all the y values are 0. So it's always something and 0 for the x-intercept. Okay, so now if you move on to 5.3, it says determine the y-intercept of the f graph. So the y-intercept, for a y-intercept, we are always setting the x to 0. So you're going to say, where is this not writing? Right. Okay, so you're going to set the I don't know why the pen is not working. Okay, so you're solving for the y-intercept, and you're going to set your x equals to 0. So you're going to say that y is equal to 4 over 0 minus 3. Let me just check if that was the equation. Yes. Minus 3 plus 2. So now you're solving for the y. So y is going to equal to 4. It's going to equal to the it's going to equal to 4. It's going to equal to 4 over minus 3 plus 2. And you can use your calculator for that. So it's going to be 4 over minus 3 plus 2. And that's going to give you 2 over 3. And 2 over 3, as we know, is 0.66. Remember, it's not a 666 recurring. It's not necessary to do this. This is just to help you when you're sketching to see where about your y-intercept sits. So again, they asked you for the y-intercept, so you have to write it in coordinate form. So it's always 0 and whatever you solved for.
Kausha.
Yes, sir?
Yeah, I have to stop you here.
Okay, no problem. It's fine.
Thanks, Kausha, for a nice lesson. There was a question maybe before.
Yeah, that's fine.
Yeah, there was a question from I think Sikulisi. She was saying, please help me with this equation.
With this?
It's ax squared plus 2x minus 24. I'm not sure. Sikulisi, what do you want to do with that? Ax squared. That's a parabola. Ax squared plus 2x minus 24. That
plus.
will be, yeah. So
I
that's
think that was one of my graphs that I did draw. Let me just see if I can go back to that.
okay.
Yeah, this is
Ah,
the graph. Yes, what happened? What's your
yeah.
question?
Let me see. Maybe just reiterate, just re-explain what was happening there, and then we can close.
Okay, so basically for this graph, we had to identify that this was in the standard form and not your turning point form. So here for the 24 now represented your, okay, let me use another color, it's be a bit easier. Okay, so the 24 now represented your x-intercept. I'm sorry, your y-intercept, which is what I labeled here as your y-intercept. So the turning point was now defined as minus b over 2a and f at minus b over 2a. So what that meant was you had to find the value of this and then substitute it back into this equation here. So when we found the value of minus b over 2a, so your b was 2 and we substituted that as 2 and your a was 1. So we substituted that as 1. So when you solve for this, you would get minus 1. So to find this, that was your x coordinate of the turning point. So you see that the minus 1 was the x coordinate of your turning point. It was this half. Now to find the y coordinate of your turning point, you had to have found this part of it. So to find that, you're just substituting this value back into my graph that was given to me. So here I would have substituted the minus 1 in, which is what I did here by saying minus 1 squared plus 2 minus 1 minus 24. And then when you solve for that, that would have given me minus 25. So your turning point is now at minus 25, minus 1 and minus 25, which is what I got here.
Yeah.
Okay.
Yeah, that's correct. Hey, thanks, Kausha. Please save that note where you were writing. I will share that with learners. Just save it somewhere. I'll send it to the learners together with the link of the recording where you were teaching. They also gonna get that. Thank you very much for taking your time. Are you at school?
Oh no, I'm at home today.
Oh, okay. No, that's fine. Thank you very much for taking your time to teach today.
Okay, thank you so much. I hope that it helped everyone and that you find functions as interesting and as fun as I do. And good luck for your papers and goodbye.
Bye. Yeah, grade 11s. Please remember that at 12, we have a science show. So again, today we are going to have a science show. So if you're gonna go out, come back at 12 because we're gonna have a science show. Alternatively, you can stay and then listen to the next lesson, which is functions for grade 12s. But again, in grade 12s, there's a little bit that is added in functions. So it's basically the stuff that you did from grade 10 all the way to grade 11, and then a little bit about 5 marks. So if you don't mind, you can stay and attend the next lesson. Or if you do want to stretch your legs, you can go out and come back at 12 for the science show. Thank you. Andrew, are you there?
I see him, but I think you forgot to unmute himself.
Oh, he has to be granted permission to unmute himself. Are you a co-host here?
Oh, let me try to make him a co-host.
Yeah.
Oh. Oh, since you are the main host, you can make him a co-host.
I'm trying to look for someone is saying when and how are we going to get the recordings? The recordings are going to be sent via the email that you used to register. So that email that you used to register, that's where we're gonna send the links to the videos and and all the slides that people were using to teach. Sweetness. I'm looking for Andrew.
All right, I think.
Oh yeah,
Can
it
you hear
is.
me?
Okay, Andrew, you're here.
You can hear me, right?
Yes, I can. Maybe come a bit closer to the microphone, but I can hear you.
Is it still the same? Is it different?
Perfect.
Perfect. Okay.
Yeah.
All right. I cannot start my video. I think I need to be given
Access
permission
to
or
show
something.
yourself.
Yes. Yeah.
Okay.
And the screen sharing as well.
The screen sharing as well.
Yes.
Let me make you a co-host. How about that? Try to share now.
Okay. Yeah, it's working.
Working.
All right. Yes. Let's do this. Just in a minute.
No problem.
Share screen. Share and let's go here. Is it okay?
Let me see. Yes, that is perfect, Andrew.
All right.
Try to write something on it.
It is writing, right? You can see that.
Can see that.
Okay, let me.
I think we are ready to go. Grade 12s, welcome back again. Today we are doing functions with Andrew Khomo. Andrew Khomo is one of my favorite teachers. He's, in my opinion, one of the best teachers I've ever seen. So he's going to be doing functions with us. Remember that after his lesson, you don't have to go away because we have a science show right after his lesson. So please stay after his lesson. Remember, in the science show, we're going to be having some prizes to give and some nice science to discuss. So Andrew, over to you, sir.
All right. Thank you, Doc. Good morning, everyone. So we're going to be doing functions today, right? These are my names. I've got a lot of names, so you can just choose whichever one you prefer. And we will be doing functions. This is going to be the outline today. So we're going to start with a bit of revision, right? Functions are nice because once you grasp the foundational knowledge of it, that's basically what you use throughout your high school going into varsity, right? So we're going to be revising that a little bit and we're going to explore some further knowledge, and then we're just going to be doing examinable exercises, right? So these are your past papers. So that's what we are going to be doing there. And then we'll end with questions, right? So here's a bit of a joke for you today. Here's a function, and it's saying, I wish I had a functional relationship, right? And if you do not get it, you will understand it a little bit later on why it's saying, I wish I had a functional relationship, right? It's like, well, you sort of have to know math in order to have a functional relationship, right? Okay, so what is a function? It's very, very important that we know what is it that we are studying, right? When you're doing algebra, you need to know what is algebra. When you're doing calculus, you need to be knowing what is calculus, right? It simplifies things in a way that you understand that mathematics is not just an independent subject, right? But it's one with nature. It is one with the universe, right? It's a subject with which we use to understand life, right? To understand a lot of things. So what is a function? A function describes a specific relationship between two variables, right? Between two variables. In mathematics, we speak about variables, we speak about coefficients, we speak about constants, right? And this term variable is basically coming from what we know as vary. So if we're saying something is a variable, we mean that it can vary, right? In other words, it can change. And that is why for variables, we use letters like your X, like your Y, like your Z, right? Because it is allowed to take on any value that exists, right? So these variables are independent and dependent. So you would have seen by now that when we write functional relationships in mathematical terms, we would say that y equals to f of x, right? So your x is your independent variable, right? That is your domain. So whenever you are asked what is the domain of a particular function, you need to give all the values of x for which that function is defined or for which that function exists on, right? And we will see a little bit later when we do examinable questions. Likewise with the range as well. The range simply speaks about the y values, right? So you can see even in how it's written here, you can only have y because you've got x, right? In other words, for every input of x, that is why it's inside these parentheses, right? It's an input, right? It's some sort of an argument. So you put on a value of x and you get a value of y. We do that all the time in our life, right? You put on something, you get a result, right? So it's the same thing. All the values of x are the domain, and then you have y. Y, we're speaking about the range, and y depends on x, right? So two or more elements in the domain may be associated with the same element in the range, right? I think in grade 12, you only studying one element in the domain, right? As it maps out with a few elements in the range, right? But that's what defines a function, right? A function is defined by many elements in the domain space being associated with either, actually one or the same element in the range space. We will see that, right? And functions can be one-to-one relations or many-to-one relations. That's what I'm speaking about. In other words, you can have more values of x, right? More arguments of x, but you can only have one argument of y. Otherwise, it's not a function. And this is why this is funny, because it's not a function, right? When you look at it, like if you look at a circle, we can't really define it as a function, but we can say it's a relation, okay? Because it does not satisfy the parameters with which we have set to define what a function is, right? So a relation is not a function if one element of the domain is associated with more than one element of the range. And you might remember from your grade 10 classes as well, you were given a few ways to test if a graph or if a plot is a function. We had vertical shifts, vertical testings, and we had horizontal testings, right? And that's what defines what a function is. Okay, I can't really see well, but this is a parabola. I'm not really sure why my screen is not full, but this is a parabola, right? It's a bit of a summary on how parabolas are. So you can either say it's a parabola or it's a quadratic function. And this is generally the way in which we know that it's a parabola, right? My pen is not working. Let me see. Okay, there we go. Okay, I think it's just a bit slow, but this is just generally how the general formula for a parabolic function, right? And we can also call it a quadratic function. You will know that expression of y equals ax squared plus bx plus c, right? This is why we can also call it a quadratic function. And this is basically the summary, right? So Q tells you about the vertical shifts, right? So if Q is positive, then your graph would be shifting upwards, right? And if Q is negative, then your graph would be shifting downwards, right? And you can see what we are talking about these ways. If it's positive, that if Q is greater than 0, you see that your graph shifts a little bit up, and if Q is negative, it shifts a little bit down. And these are very important because sometimes, especially in the first question of your final exams, you find a whole lot of bunch of text written and they tell you that you need to plot that function. So it's very, very important that you know these things. And then you have the value of P. P is a bit counterintuitive because if it's positive, then your graph shifts to the left. And if it's negative, your graph shifts to the right, right? As in this case, you see that P is positive and your graph has shifted to the left, right? Normally, you would just think that if things are positive, they shift to the right. And the reason for that, because we normally just equate that to 0, but you will see it when we are doing questions. So this is your hyperbolic function, same thing, right? Same thing. And with your hyperbolic functions, we would be speaking about asymptotes, right? And asymptotes are these dotted lines. Your graph can only approach them, but they can never touch them. Why? This is because on your asymptotes, your function is 0, right? And you will see when we do questions that we actually just normally take this and equate it to 0. You can check it in your calculator. If you divide anything by 0, it says it's undefined, right? And so these asymptotic lines are just points on your graph where your function is undefined, literally where you have just divided by 0, right? So normally we would just say, okay, we have x plus p, and we're just going to equate that to 0. And then if you want to find the equation of that asymptotic line, which is a vertical line, you just say x would equals negative p, right? And then the horizontal one would just be y equals q. But everything else is still the same as on the parabolic case. That is P, it's just the horizontal shift, and then Q is the vertical shift, right? This is a summary. This is generally how your parabolic functions would look like, right? And then you've got exponential functions, right? We've got restrictions with exponential functions, right? Like your B cannot be 1, right? Because if it's 1, then this is no longer an exponential function, right? Your B cannot be 0, it cannot be 1. Your B can only be between 0 and 1. But those are just restrictions that we have so that we make this function an exponential function. It's called an exponential function because of that exponent there, right? Your independent variable is at the exponent, and then everything else is basically just the same, right? But this is the general shape of your exponential functions. Okay. So let's do this. This was taken from a past paper, and this is just extra. I think you only have this in grade 12, right? It's about inverse functions, right? It's about inverse functions, and I thought it would be a little bit easier when we just try to understand them with an example, because there's not really, it's like a small chapter. Okay, so question 6, you've got the graph of f of x that is equal to the logarithm of x, right, to the base 4, is drawn below, right? And so you are given a point, we call it B, right? The x value is k and the y value is 2, is a point on f, right? Literally, that is what you have. And the first question is that you need to calculate the value of k, right? So with these questions, everything that you need to use, it's like, for every question, there's always information that you have available at your disposal to actually solve that problem. Okay, so for this one, calculate the value of k. Where is k? K is just an x value, right? Obviously with some y value, but on the graph, that's the only point that we have. So how do we find that? We are given a function, and that is f of x. I'm not really sure why my pen is a bit slow, but hopefully we can work with it. So f of x is equal to the log of 4x, right? this is the function that you have. So how do you determine the value of k? You go to your graph and you see that it's at a point B, k is the value of x. So wherever you have x, you just put on the value of k, right? In other words, you will say, I'm looking for f of k. That is literally equals to the log of 4. K equals to f of k is your y value. And so that's going to be 2, right? And so if this is a little bit of a distraction for you, you can then just say, okay, I've got the logarithm of k to the base 4 equals 2, right? So this is what you have. And if you remember in your classes, this is just the logarithmic expression, right? Quite awful, but it's just a logarithm expression. And you've got the log of base, right? And this is your this would be your exponent, and this would be the logarithm of that particular function. So it's like when you have something, an equation written in terms of exponentials, you can convert it into logarithms, right? And the way in which we would do that is to say, okay, I've got 4, it's literally at the base. And so even if I write it in a normal way, I'm just going to put it here down, right? But with exponent 2, which is this one, that would equal what? The value of k, right? And so the value of k would then just be 4 to the exponent of 2, which is just 16, right? So that's pretty much it. You don't just have to be confused by, try not to be confused when you're taking this from here to here, right? Just know that it's the logarithm of k, right? K is the subject of the formula here, and the base, you can still think of it as a base here, raised to the exponent 2, right? In other words, when you're writing any expression that has got exponents in it, especially if it's an equation, you will be able to write it in this way, right? And so k would just easily be found to be 16, right? And so you go back to your graph, you upload that, yeah, but I mean, you plug that on, and it's just going to be 16 and 2, right? So you now have that point on your graph. Now, the second question, determine the values of x for which -1 is less or equals to your f of x, which is less or equals to 2, right? So on this case, you have f of x, right? It's been given to you. It's the log of 4x, right? So you are basically asked to find values of x for which your function, in other words, this function that you're given here, is between -1 and 2, right? And so -1 and 2 would be somewhere here and there, right? So you are required to find the values of x for which this function, f of x, is between what? -1 and 2, right? That is, it's greater than -1, but it's less than 2. So how do you do that? You use what you have, right? So you will, okay, let me just make a star here. So you can solve it, one of the ways that I'm going to show you, a simplest way to solve this. So you can say, okay, we have -1 this side, and you just plug in what you have, which is the function, and that's going to be the log of 4 x, right? And then less or equals to 2. So how can you do this? You can try to solve this first, right? And solve that, because either way, you're still going to get x at the center, right? So you can, for example, try to say we have -1. We've got -1. That would be, you can say less or equals to log of 4x, right? And so you basically use what we've just explored here about the logarithms, right? Taking them to this exponential form. And when you now have -1 equals to the log of 4 of x, you know that 4 is the base, and so it's going to come here, right? You know that -1 will be the exponent. So we have -1, and you would basically just be having x on the other side. So it's like you x on either ends of your restriction. That is your inequality, right? So we have x equals to -4. We can write this as x equals to 1/4, right? So we have this on one side of this equation. And on the other one, you do the same thing for 2. And if you do it for 2, so that'll be like log of 4, right? Okay, my writing is all over the place, but hopefully you can see. Log of 4x, and then on that side, you have 2, right? And if you use the same method that we use to basically take this from here to here, this is just going to be x equals to 4, right? That is the base raised to the exponent of 2, right? And so x in this case is still 16, right? So if you see what we did here, we looked at one side of this, that is the first one, -1 less or equals to log of 4x, right? We found x, and then we looked the other side, which is log of 4x less or equals to 2, we found x. And because it's x, same x that we're solving, we can then just basically take x 1:4, with which we found when we calculated this on this side, we just put it here, 1:4 less or equals to x, right? Great, less or equals to that would be 16, right? It'll be basically 16 on this side, and you can still put the inequality signs when you are sort of solving it. Okay, so we first started with this side, we did the same thing that side, and because literally you're just having the same value of x, you would then just be taking it down to say, okay, for this side I found x to be 1/4, and for that side I found x to be 16, right? And so you can just put it on the other side. Okay, all right, so 6.3, write down the equation of the inverse of f in the form of y. Now, the inverse means a reverse of what we know, right? So for example, if I have y equals to 2x, and this is my function, and I'm asked to find the inverse of this function. The inverse, remember we said it's a reverse of what you have. So where you have x, you will put y, and where you have y, you will put x, right? So how are we going to do that? That means you will have x, where you have x, you put y, and where you have y, you're going to put x, right? So when you do that, this is just going to be x equals 2y, right? And then you are asked to express this in terms of y. You just solve for y, right? And how do you solve for y here? You just divide by 2 on both sides, right? And when you divide by 2 on both sides, you have y equals to 1/2 of x, right? Because you just divided by 2 on both sides, okay? So in this particular case, our function is given as f of x equals to the logarithm of 4. My pen is a bit slow again, but f of x is equals to the logarithm of base 4. It's actually the logarithm of 4 to the base, the logarithm of x to the base 4. Quite mouthful, but that's how you say it. It's the logarithm of x to the base 4, right? So how do we find the inverse of this function? You do the same thing. In order to make things easy, you can write this as y, right? So you can equate it to y, right? And so we're just going to look at this side. And so what do we do from here? You basically exchange the variables. That's the meaning of an inverse, right? When you exchange the variables, you have the logarithm, right, of base 4. Where you have x, you put y. And where you have y, you put x. This is what you have, right? And so how do you now turn this to a standard form with which you know, with which you've been taught, right? How do you do that? You know that this is just an exponential form, right? So literally, you can have 4 on your base, still base, right? And x will be the exponent, right? And then y will just be on this side. Okay, let's see. Then you have y on this side. So in other words, the inverse of this function would now be y equals 4 raised to the right. In other words, this is an exponential function. Function, just simple, right? So now your inverse function. And so we have now just answered and you have gotten your 2 marks. Okay. Now the last question, for which value is be true, right? So for which values of x will, okay, let me try to erase this so that you can see it well. Probably my internet is a bit slow, but okay, let's okay, this is not gonna work. This is not gonna work. Okay, let's just do it. So the question is, my computer's a bit slow again, but this is what we're trying to find. We want to find the values of x where this is true, right? That is where x times by the inverse, right, times by the inverse is less than 0, right? So you want to find the values of x where this inequality is true, right? So just substitute your function for f or for the inverse, right? So this is going to be x. The inverse is 4x. We've just found that right here. So it's going to be x times by 4 to the x, where this is less than 0. So if you think about this, you look at this and you say, okay, I mean, well, what does this mean? This is literally asking you to find the values of x where this new function is negative, right? Because anything less than 0 is negative, right? So you need to find the values of x where this new function that you have is less than 0. That is where this new function is negative. And how do you do that? Well, this can only be true if x is less than 0. And why do we say that? That's going to be the only way where this can be negative. Why do we say that? That is simply because, I mean, well, this is true. I can say x is going to be 0, but if we look at this case, like 4 to the x, it doesn't really matter what value you put as x. You will get a negative, I mean, a positive value, right? For example, if we say 4 raised to the exponent of -1, that's just 1/4, right? If you say 4 raised to the exponent of -2, it does not make this negative, right? So this is basically just 1/4 squared, which is a positive value, right? If still I say 4 to the squared, that is 16, right? So this doesn't really have much impact because it's always positive, but this on this side, which is x, is the only term, well, not really a term, but it's the only variable that's going to to make this new function be negative, right? And that is if it's actually less than 0, right? So you can write this in this way, or you can say x is just an element from -infinity all the way to 0, right? In other words, from -infinity downwards all the way to 0, right? And 0 is not included, of course, because we're just having a strictly less than inequality sign, right? So I hope this makes sense. And if you do have questions about it, you will ask towards the end, right? So that's pretty much it about the inverse functions. And that is how you work with the logarithms, and that is how you actually find all the values of x, for that inequality function. Okay, right. So here's another one, and it's question 4. It's also an examinable question, right? Sketched below is the graph of h of x equals 1 divided by x plus p plus q on the side, right? And you are told that the asymptotes of h intersect at 1 and 2, right? In other words, they intersect here, right? And this is just your hyperbolic function, okay? And if you do remember, we at the beginning of the lecture, we did say that when you want to find the equations of your asymptotes, you basically say x plus p, that is the one in the denominator, you equate that to 0, right? Why do we equate this to 0? This is because asymptotes, by definition, are points on your graph where your function is undefined, right? That is why normally we say, so your graph will approach your asymptote, but it will never touch it, right? Because when it touches it, it gets undefined, right? It does not exist, right? So this is why we're dividing by 0. We take the expression in the denominator, we divide it by 0. Well, if I equate it to 0, I'm literally now just saying x plus b is 0, right? And now making that function undefined, right? So what will be the equation of asymptote in this case? It's just going to be x equals negative p, right? And the other one, in likewise manner, will just be h of x equals to q, that is y equals to q, right? So the very first question for 2 marks says to you, write down the values of p and q. When you know that, you can figure out what that is. But in this question, you are told that your asymptotes, they intersect where? At 1 and at 2, right? So if you do this, if you take this equation, you can just say the value of p is actually just going to be negative 1, right? Why is that? Because this is literally where they intersect, right? So this vertical line is literally at x equals to 1, which is at this point, right? And this horizontal line is at y equals to 2, right? And so if you know this, you can then just say, okay, this is just x equals 1, right? This is x equals 1. But if I want to find the value of p, I'm just going to bring 1 to the other side, and this will be x minus 1, right, equals 0. And now the value of p will then just be minus 1, right? Or you can just say x equals minus 1. That's how you find that out, right? So your your p will be negative 1, and then your y will be q, right? In other words, your q is just going to be 2. So y is 2, which is what? Which is q, and x is negative 1. And if you look at that, just by looking at this graph, you can see that my graph actually did shift 2 units. Is it? Oh, this is actually supposed to be q, but it actually did shift 2 units upward, right? You can see that it shifted from the origin 2 units upward, right? And in this particular case, remember I said it's a bit counterintuitive. In other words, if P is negative, your graph shifts to the right. But if P is positive, your graph shifts to the left. In this case, P is what? It's negative, right? And you see your graph has shifted 1 unit to the right. Okay. So that's what you have. So the P will equal -1 and Q will equal 2, right? Just okay, still have some time. All right, so Q will equals to 2. So the second question, calculate the coordinates of the x-intercept of H. H is the very same function that you are given here, right? So the x-intercept, this is why it's called an intercept, because it's literally where your graph intercepts the x-axis, right? It's where your graph does what? It's where your graph intercepts the x-axis, right? So anywhere your graph intercepts the x-axis, your y value is 0, okay? So where's our x-intercept here? It's probably here, right? You can see that, I mean, it's literally just crossing the x-axis here, and well, wherever it will cross it, whether it's that side, whether it's that side, whether it's that side, your y value will always be 0. And that is just why when we ask you to find the x-intercept, you know, it's a bit of a station. Now you can just say, when we find the x-intercept, you just have to make y 0, right? You just have to make y 0. In other words, your h of x is 0 equals to 1. Now you write your function, right? X minus 1, right? Plus 2, right? And then it's just algebra to solve for x, right? It's just algebra from here, because you can take 2 to the other side and it's going to be -2, 1, x minus 1, right? And what can we do? We can multiply by x minus 1 on both sides of the equation. If you multiply by x minus 1 here, you multiply by x minus 1 here, you'll have -2 times by that. You have -2 times by that. And let me just give you the final answer, because it's basically algebra. And if you have a question on how we solve that, you can ask it at the beginning. But I have already done this. So you will find that your answer, which is your value of x, in this case, let me see. Okay, it's just going to be 1/2. Okay, it will be 1/2, right? But you always have to write down your answer in terms of coordinates, right? So how do you write that in terms of coordinates? This will just be 1/2, and you know, because you equated y to 0, so you have to put this here. Okay, I hope this makes sense, but it's just algebra from here, and it can be a homework for you. Try to solve this and actually check if you find -1/2. I mean 1/2 and 0. Okay, so try doing that. All right. So the third question. Write down the x coordinate of the x-intercept. Okay, again, the x-intercept of g. Now, g is a new function that they're defining here. The function that we have here is not g, but it's h, right? So they're defining a new function. Write down the x coordinate of the x-intercept of g if g of x equals h of x. It's not h of x, but it's h of x plus 3. So how do you do this? This is what you are given. You are given this. Okay, so we are defining a new function, and we say it's h of x. And this h of x is equal to h of x plus 3, right? Good. Now, remember that our function h of x is basically 1, I think x minus 1. And let's see, plus 2, right? Plus 2. Let me see. Yes, that's it, right? So this is your function. And so you need to find the x coordinate. In this case, they're saying the x coordinate, right, of the x-intercept. Why are they particularly saying the x coordinate? Because you're going to always have to, I mean, we're dealing with functions, so it's pairs, right? So it's x and y. So in this particular question, they're only looking for the x coordinate of the x-intercept point on your graph. So how do you do that? You simply, I mean, where you have x, you are now given x plus 3, right? Where you have x, you're now given x plus 3. It's now no longer x like this, but you have h, right? In other words, you simply just say, okay, I'm going to take my x of h, and where I have x, I'm just going to put x plus 3 and see how that's going to work out. So that's going to be 1. Where I have x, I'm putting on x plus 3. So it's x plus 3, right? Minus 1 plus 2. Okay? So this becomes 1, right? We've got 3 minus 1. And this is x plus 2 plus 2, right? It's x plus 2. This is now your g of x, right? So when you're given something like this, you do know that here it was just h of x, right? It's a function of, but they're changing the argument, right? They're changing the domain space, right? They're changing the independent variable, and they're just adding to the x that you already have, they're adding 3, right? So that's why you take that function that you have and you just add on 3 and you simplify, and this is what you basically get, okay? And remember what the question said. The question said you have to find the x coordinate of the x-intercept. In other words, you kind of have to find the intercept in this particular case. And you have to do that. What do you do? For the x-intercept, you make y 0, right? For the x-intercept, you make y 0. So that is 0, 1, x plus 2 plus 2 on the other side, right? It's just algebra again here to find the value of x, okay? But what you are going to do, you take 2 to the other side of the equation, right? And mathematically what that means is that you minus on both sides of the equation -2, right? And so if you take it to the other side of the equation, you'll have 2 equals 1x plus 2, right? And then you can multiply by the denominator on both sides. But the answer that you should get, again, I did this, the answer that you should get, so I'm just going to give it to you as a homework to try and find, or you can quickly solve it and actually find that the value of x will be, let me see, the value of x will actually be -5/2. Okay, it's just going to be -5 divided by 2. So that's what you should get. I'm just going to give it to you as a homework so you can actually see if you're getting to this point. Okay. All right. So the fourth question, the equation of an axis of symmetry of H is y equals x plus t. Okay. So now we're introducing a new term, axis of symmetry. What's that? So those are the equations that would divide your graph into 2 similar parts, right? When we're saying something is symmetrical, we mean it's the same on both sides, right? So if you think of a ball, right? If you think of a ball is a sphere. It's symmetrical, right? Because wherever you're going to cut it, if you actually cut it in half, both sides of the ball would actually be the same. So that's symmetrical, right? So you're given a new function. It's y equals x plus t, and they've actually made it much more simpler for you. You just have to find the equation of an axis of symmetry. And in this particular case, you use what you have, okay? For every question that you get, you do have something that's given to you that you can use, okay? So for this, just take the equation, take the coordinates of the intercept of the asymptotes, right? That's what you're going to take, because either way, the equation of symmetry is probably going to lie there, right here. So you take it, actually passes through the asymptotes, right? But in a more of a skewed way, right? So take the points of where the point that you're given, right, of your asymptotes. Take that point, substitute it, and actually find the value of t. And let me see what the question said. Okay, you are just, okay, you need to determine the value of t, right? You need to determine the value of t. So we do remember that the point that we have, it was 1, 2, right? I think that's what we were given. 1, 2, right? The value of x is 1, the value of y is 2. That's the point that you are given. So you just use this, right? Where there's x, you substitute that. So you're gonna have 1 plus t, right? And for y, you will be putting on 2, right? And you solving for t in this case, right? Easy stuff. So t will just be 1, because on both sides of the equation, you just minus 1. And so t will just equal 1, right? And so your equation of axis of symmetry in this particular case, it's just actually going to be x plus 1, right? So this is basically what you're going to have, okay? Right. And the last question, determine the values of x for which -2 is less than this expression here. And if you remember, this is actually, so they've taken the value of q, took it to the other side, and just put an inequality sign here, right? This is still a bit of a, it's still a bit of a, you know, an algebraic thing that you have to solve. Let's try to do it. I don't have space anymore. I'm writing all over the place. Let me see. Okay, I'll just quickly do it here. So you have to find the values of x. So what they're simply asking you in this case is that you solve the inequality. Okay, you have to solve that inequality. So you're going to have -2 that's less or equals to 1 divided by x minus 1, right? So you can choose to multiply both sides of this inequality by x minus 1, right? Like we did. So it's going to be x minus 1, right? And so okay. So okay, let me do this. You multiply it this side, right? It's x minus 1, and you multiply it on that side. It's x minus 1, right? So you do see that they're going to divide each other, right? Here, and on this side, you're actually going to get 1. Okay, and now you just distribute. It's -2 times x, that is -2x. -2 times -1, +2, right? Less or equals to 1. Okay, and -2, -2x, right? Less or equals to, that's 1 minus 2. I think that should be 1, right? And so the value of x, when you divide here, you basically divide it by a negative number. It should change the inequality sign. And was this negative? It's negative. And so you're going to get 1/2. 1/2. Yeah, you should get 1/2. You can let me know if I did anything wrong, but this is what you should get, right? That's what you should get, because you've taken 2 to the other side, and that was equals to -1. And you divide both by -2, right? And that basically changes the inequality sign. Okay, I think this is This is correct. Okay. All right. So that's pretty much it. Especially with these kind of functions. So anything and everything that you will be asked, you will be given enough resources at any time to basically solve your problems. Okay. So I think we've got about 5 minutes, and maybe we can try to do this just to check what's happening here. Maybe we can do the first question, quite an easy one. I do not see, I'm not sure why, but I can't really see my whole screen. So, okay, I'm not really sure. I can't see my whole screen, but you're given this particular function.
Maybe it's a sign, Andrew.
Maybe it's a sign. It's okay, but you guys can take a picture of this and try it at your own time, and take it as a homework so that you can work it at home. But yeah, all right. Thank you, Doc. We will stop here, and I'm not sure if there are any questions.
Let me see. I was not intending to take questions, but I'm gonna say 1 minute for questions. If you have questions or a question, you can just raise your hand. Use the raise hand function. I'm saying 1 minute because we need to get to the science show now.
Yeah.
Okay. No, Andrew. Thanks, man. Nice lesson as usual. Please share these slides with me so that I'm going to share. I'm going to share them with the learners. Yeah.
All right. No,
Yeah.
thank you very much, Doc, and thank you so much. All right, thank you. Let me just unshare.
All right, learners, in about, let me see, in about 2 minutes, we are going to have a science show. So don't go anywhere. Just stick around for 2 minutes, and then the science show will start. Thank you. Pillay, how are you?
I'm good. How are you?
Good. I'm not sure whether you can hear me. There's some heavy rain happening here.
Yeah, I can hear you.
Okay. Do we have people from environmental sciences? And
I'm trying to call him,
okay,
but he's not picking up.
all right. Just give him 1 minute.
Yeah, maybe 5 minutes.
Okay. Any luck?
No, not yet.
No, it's fine. I think we can do just the lucky draws.
Oh, okay.
Yeah, so you have to have the spreadsheet in front of you.
Oh, okay. The
Spreadsheet of
those who registered.
yeah. And then I'll
Okay.
give you a random number and you're gonna tell me which number corresponds to, let me know whose name that number corresponds.
Okay, I'm just gonna extract it now.
Okay.
Should I use the one for those who attended or the ones who registered?
Attended.
Okay.
Yeah, so guys, how this is gonna work is Snare has a list of everybody who's participating in this program, and she's gonna extract only the names for people who attended so far. And then I'm gonna give her a random number, and whoever that number corresponds to is gonna go away with some, for three people, whoever is lucky today is gonna go away with some nice UKZN and some nice things from me personally as well. So just stay with us for the next 5 minutes or so. Now you let me know once you're done.
Okay.
Okay. I just have to make sure that it doesn't correspond to me. Or Andrew. Andrew, don't worry, you're gonna get your things. This is for exclusively for learners.
Simo, I can't extract today's register because the meeting is still on, but we can use the registration.
Let's use the registration one then.
Okay, I have the registration open. Should I share it?
No, you can't share it. I'm supposed to see it.
Okay. We can start.
Right.
Yes.
Oh, okay. Let me see. My favorite number is 5. Let's start with 5.
5. 5, it's Yonela Skisazana.
Yonela Skisazana. Do we have Yonela here? I think Yonela was here yesterday. I haven't seen Yonela today. Okay, no, I don't think she's here. She was here yesterday though. Let's go to, let's try 11.
11, Tando Mazibuko.
Tando Mazibuko. Do we have Tando here? Also, I think what you should do, Sneh, just unmute everybody so that it's gonna be easy to identify them if they are here.
Okay.
They can just unmute themselves. Okay, let's try 21. Prime numbers.
You 21. Said 21.
Let's start with 21 here.
Fanele Mqadi.
Mqadi. Panele is here. Let's change to 50.
Ayabonga Zondi.
Ayabonga Zondi. Is Ayabonga here? Give me 100. Who's on the 100 spot?
Nelish. Oh, it's Nelish. Nelish Papo. Something there. Nelish Papo.
Something delicious here. So let's try. How many people do you have in that list?
1, 230.
230.
Yes.
Yo, that's a big number. Okay, let's try 215.
So 15.
Mm-hmm.
It's Shimlin Govender.
Shimlin Govender. He's here.
He's here?
Not yeah. Please, he's here. And please unmute yourself.
Oh yeah, he's here.
Yeah. Hey, I don't think that's how you pronounce that name, man.
Yeah. Sorry with the pronunciation.
I'm here.
Yeah. Let me
I'm
just.
here.
Yeah,
How
I
do I pronounce your name?
Shamalan.
Shamalan. Okay.
Yes.
Yeah.
Shamalan.
Maylin, please give me your cell phone number on the chat box if you don't want to.
Yeah. Okay, no problem.
Just type it in the chat box. Yes. Okay. Dubazana, please give me your random number. We have one so far.
Let's try 100.
100.
Yeah, 100.
We already tried 100.
You already tried 100, man.
Yeah.
Okay, 120.
120. It's Moin Motley.
I don't think we have them here.
Okay, 150. 150.
I apologize for the pronunciation.
What's the spelling?
It's SNETHOORAN. Naido. Yes.
Naidu.
Naido.
Oh, she's here.
Oh, yeah. I see. Yeah.
Oh yeah,
Naidu, please unmute yourself.
Hello.
Yeah, before you say anything, please teach her how to pronounce your name.
It's Centurion.
Centurion.
Oh, Centurion.
Okay.
Okay. Please type your phone number in the chat box. Send your phone number to me via chat box. Okay. Let me try. One lucky person remaining. Let me try 7.
7.
Yeah.
Andy Lesibia.
Is Andy Lekaba here, not Sibiya?
Oh, he was here some time ago.
Yeah,
Today.
Even today?
Yeah, even today.
Oh, unlucky then. I know yesterday I saw that name yesterday. Okay, let's try 77. 77.
77. It's Mandy Tusi.
Mandy Tusi. We have Mandy here. I don't see Mandy. Centurion, please give me a random number. Maybe yours. Maybe your random number. Just not yours.
97.
97.
It's Carolite George.
Caroline George. I don't think we have that yet. Try another number, Centurion.
160.
160. 160.
It's Sahana.
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 Yeah. Siyabonga. Try your luck.
200.
200.
Yeah, 200.
It's Samantha Mfeka.
Samantha was here. Attended one of the sessions.
No longer in the meetings.
Ah, I see. Unlucky. Okay. Let me try one more time. Please give me, you said we have 260, right?
Yes.
Please give me 222.
222. Khayelihle Moya.
Khayelihle.
Khayelihle Shaun Moya.
No, they are not here. No, they are not here. Okay. Who's at number one? Let's try number one. We didn't try number one.
Number one, I think it's you. Yeah, it's
No, that one.
limited.
That one. No. That one is not. Who's the last person?
Lamuli Ndlovu.
No. Hey, Andy Lesbia is here now. Just join.
He's back.
Yeah. So we can take.
Oh, yeah.
Yeah, we can take Andy Lesbia then.
Okay.
Yeah, Andy Le. Andy Lesbia.
Okay.
Is
not.
You were saying?
Oh, I was saying that he's not muted. He's muted.
He should be able to unmute himself.
Yeah. Please mute them, unmute them. Andile. Oh, there you go. Andile Sbia, please give me your cell phone number via the chat box. Okay, guys, I think this is where we're gonna end today. Tomorrow, what are we doing tomorrow? We are doing Euclidean geometry. Very important subject. It carries a lot of our exams. So please make sure you attend that one. It will be very, very nice. The teachers for UKZN were also carefully selected. So they are good with UKZN geometry. So Andile, please do not go away. Sending me your cell phone number. And by the way, guys, all the recording will be sent by Friday, together with all the material, the slides, or everything that throughout the week. We'll send that to you by Friday. So guys, let's see each other tomorrow. Nila, please send me your cell phone number. Don't go away, Andy. Okay. Okay, got it. What's there? Anything?
Nothing from my side.
Okay. Tubazan, anything from your end?
No, nothing from my side.
Oh, okay. Cool. Let's meet tomorrow. Tubazan, who's doing the chat box tomorrow?
Ntokozo.
Oh, okay. But I think you should come in any case.
Oh, okay. All right. No problem.
Tomorrow we have a call science show from someone from chemistry. Yeah, it will be a live show.
Yes.
Yeah.
Yeah. So it's Conrad and his team. I'm not sure.
Yes.
Yes. Last year they did a nice science show. Yeah. Yes. Of Conrad. Okay. Last year he did it with Tanya. Is Nell still around?
Yes, she did.
Yes, I'm around.
Yeah,
Yeah, they say they're having a separate. Tanya will do hers on Friday.
Yeah. All right, no man. That's it. I think that's it from my end, guys. Thanks.
Bye.
All right. Tomorrow.
More.